Welcome to my live session every day in the evening on various topics from my toolkit. And this week, for the next 7 weeks, I'll be talking about smart manufacturing, which I felt quite impressed with the amount of what should I say, talk that is going on, and I thought I'll also share my bit. So that's the reason why I jumped over to smart manufacturing for the next 6 or 7 weeks, and then I'll get back to the original way of sharing some wisdom about one tool or method during a week. So before I start, a very brief introduction of myself. Dinakar is my name. I'm the founder of Samuthana and the inventor of Do-How, a methodology for changing leadership, for changing the leadership using the understanding of mindset and culture. That is what you see here at the bottom. That's the You can watch videos. There are a lot of videos on mindset and culture, and on the other side, to really talk about acquiring management skills and leadership skills by using PDCA cycles. What you see on the left side is about smart manufacturing, which you will see and come to know in the next 6 weeks. This is the pictorial which I have got, a representation of both the areas of leadership and management. And what we basically do is drive people to achieve challenging goals. And while they do that, they acquire leadership and management skills, and at the same time, change their mindset and culture, and move forward on the journey of smart manufacturing. For example, right now with one of our clients, we are working on. We are putting in place smart reports, which is some kind of a workflow automation, which really makes the life easier. Anything to do with making life easier and reducing the dependency is all smart manufacturing all about. So with that brief introduction of myself and Do-How, I also would like to request you to visit dinakarmurthy.com in case you want to know more about what we do, or write an email to me. Dinakar@samuthana.com is my email address. So with that brief introduction, let me directly jump into the topic of the day, which is smart manufacturing. I'll start with an introduction, and then introduce this week. I would talk about the product cycle. I'll share that very in a minute. There's some problem with the flickering which is happening, so now it's good. So let me start with the introduction of smart manufacturing. See, I would say that smart manufacturing is using hardware and software technology for assisting to fully managing repetitive tasks within an environment or ambience. As simple as that. Tasks which are mundane, which is repetitive in nature, to manage that and to really use technology to do that is what smart manufacturing is all about. Now, when you look at the smart manufacturing per se, on the left side, I explain the overall context there. You have an environment. In the environment, which could be a couple of machines, couple of people, everybody is in the environment. In that environment, the first thing that would happen is there would be some kind of a sensing which happens. It could be what we do physically. We possibly hear, listen, or we possibly touch something and read something, and that is the sensing that happens. And based on the sensing, our mind would define and would correct whatever we had done earlier, and then define a plan. And based on that plan, an actuation is done, and again the environment changes, the situation changes, once more sensing is done. This is a simple PDCA cycle. So if you look at the control loop of any smart manufacturing, the first activity would be to control something. So you need to control. That means there should be some kind of an algorithm for controlling it, and based on that algorithm, some actuation is done. Actuation could be moving a cylinder, could be sending an email, could be uploading a program to a robo. Some kind of an activity is actuation is all about. And once actuation happened, then something would be carried out. That is the purpose of actuation. And when that happens, you again start sensing as to what are the outcome of that, and that's called as a closed loop control. So once the sensing is done, then that sensing is used for correcting the plan and the control algorithm which was developed. So it's a continuous loop of controlling, actuating, sensing, and correcting, or in other words, plan, do, check, act. This is a very popular Deming cycle. Now, using this cycle, I've tried to explain the smart manufacturing in 6 different cycles, starting with the product cycle. I call it the product cycle, process cycle, people cycle, performance cycle, productivity cycle, programming cycle, and finally progression cycle. So if you look at it, the smartness basically is there in the individuals, human beings, already in the organizations. But when we talk about smart manufacturing, it's about getting the machines to do the smart activity what the humans are doing. That's the fundamental idea of smart manufacturing or industry 4.0. Now we're talking about industry 5.0, and there are already articles about industry 6.0, which could be some kind of self-sustaining societies, much bigger than what we are talking about today. So let us now get into the product cycle. That will be the topic for the week. This week I'm only going to be talking about product cycle. Next week I'll talk about the process cycle, people cycle, performance cycle, productivity cycle, programming cycle, and progression cycle. As I said, in all the cases it's very simple. You start with the control and then plan something, then actuate it, do it, sense it, where you are checking the outcome, and after that correcting the control at the idea or the algorithm which we had. That's what is called as machine learning, where you are constantly learning continuously and correcting the prediction. Machine learning is used for prediction, which is based on which is what happens during the control activity, and this prediction is the one which creates an actuation, and based on that sensing is done. Sensing can be any physical parameter preferably, and then after that based on the sensing there will be a difference between the prediction and what we sensed, and that correction is what that gets updated into the algorithm. That's the fundamental principle. And incidentally, it is the same way our human mind also works. Human mind works the same way. I think one of these days I had spoken about the mindset and culture, where our mind basically is mindset is nothing other than a collection of experiences from our past life, and these are all stored as memories, and based on these memories a unique framework is formed for all of us, and that framework is called as mindset. And based on that mindset, the mind is constantly doing predictions. And again, this is something which you can read through. It's called as readiness potential, where the mind does the prediction of what's going to happen in the next what needs to be done in the next coming instants and seconds on a real time basis, not just one off. And that is happening 500 milliseconds ahead of whatever that we are supposed to be doing or will do at that particular moment, and that happens in a subconscious level. And consciously we come to know that only 200 milliseconds before, and then we execute the particular action, execute it, perceive it. See, I keep telling this example. Early morning when you wake up, you are sleeping and eyes were closed, and you really woke up and open your eyes, you find it difficult to find where the switch was, where the phone was. Whereas the same thing you do after keeping your eyes open for maybe half a minute, then it just works like a jiffy. There's no need for you to find out. You can easily make out where is located, which item is located where, because your mind already did the prediction to say that it could be located there. So look at that particular point. So that's the fundamental essence of smart manufacturing, to be able to control, in which case we are trying to predict something, and based on that prediction some actuation is done, based on the actuation sensing is done, and based on the sensing a comparison between the prediction and the actual outcome, and that gets corrected into the control algorithm. That's the essence of machine learning. I'm not really a software guy, so I know a little bit about software, I know a little bit about engineering, and so from that background I speak. So I'm more a application person, so if somebody wants to really talk to me, it will be more about the application in manufacturing rather than programming and coding. That's not my forte. So now let me start with the product cycle. The first part of the product cycle is the control or the plan phase, where we are trying to get a product idea. That's the basic idea of the product cycle. First is you need to have an idea, you need to have a product idea. So how can this be done? That is what I've tried to explain here. How is this being done in the industry today? And to see what can be made as a smart way of working. First is, one of the basic things that I used to do, and I have done quite a lot in my professional career, is what is called as an idea workshop. Idea workshop is getting people from diverse functions, or all the experts in R&D, purchasing, manufacturing, then sales, application engineering, systems engineering, then software development. So every expert from each of these functions would come together to try to find out what could be the future versions of the product. Generally, idea workshop is more suitable for finding out the next generation of the product, which would be some kind of a further development ideas is easier to generate there rather than totally fresh ideas. But still, in the idea workshop, you're creating a kind of a free thought situation, and that can be done using do how. That's again something which you need to just keep in mind. It's not something that needs to be done, but do how does create free thought. So idea workshop is basically for that kind of a free thinking environment where one could generate ideas about new products and new applications. The other way of finding out product ideas is using a blue ocean workshop. When you take blue ocean strategy workshop, you're talking about trying to do a market canvas, trying to understand the market, and based on that try to understand what the limitations of the existing product are and whether these limitations can be integrated into the existing product. One of the examples which was quite interesting was in the high-end cars. That's really a very crazy thing to be doing. High-end cars, they also provide an umbrella with a logo of that particular company on the umbrella, and that's basically a very interesting situation. See, when you have a car, you are clear that you can't leave the car and not get drenched. So that this particular car has a place where you can keep the umbrella, and the umbrella has the logo of that particular car. That itself is a huge symbol, a status symbol for people to walk around. It could be Maybach or Bentley. These cars or Rolls Royce. So they offer this feature. Interesting. Technology. That's a limitation in that particular industry. Limitation is automobiles. Once you get out of the car, you'll get drenched anyway. So working on the limitations could mean that you put a package, a new product model, and then sell it. That's the idea of blue ocean strategy. Then the other thing is to do scenario. These two, idea workshop and blue ocean strategy, cannot be done using technology because it is basically human beings who are doing the ideation. But technology can be used to trigger. And that's what DoHo is all about. DoHo triggers the thought using technology, which is a web app. And web app basically triggers the thinking using some contextual hints. And that is how the free thought happens. That is how the free-flowing discussions happen. So that's the kind of a smartness in getting people to collaborate and getting people to discuss. That's the smartness in DoHo, which can be used for idea workshop and also for blue ocean workshop. Then comes the next one, wherein the computer geeks can do the programming and then do data mining and then find out what could be happening for scenario and megatrends. See, megatrends are something which is already described, where you could talk about urbanization, you could talk about literacy levels, you could talk about the defense budgets, you could talk about the conflicts, multiple things which are, or maybe we could talk about the water scarcity, which is going to be an intense issue to be discussed in the coming years. Or it could be something to do with the average age of countries. For example, Europe has a very high average age, whereas India's average is quite low, but still it is growing. And once the average age becomes very high, then there will be a lot of old people in the country who would not be in a position to work, whereas they need to be paid because of the pension schemes, which means the balance between the earning power of a country and the expense of a country will change. Therefore, some new schemes have to be found out, new products have to be found out, and so these are all the mega trends. So on one side there is mega trend. Second is scenario analysis. Scenario analysis could be, let us say, if Bangalore, we stay in Bangalore. Today Bangalore's population is about 10 million people. Imagine Bangalore's population growth is going to stagnate, and what's going to happen? What will be the scenario? What kind of environment will exist and what kind of products would be required here? Or let us say Bangalore's population is going to get doubled in the next 5 years. What would be the challenges? Or it could be that now today, because of the advent of internet and 5G, imagine the speeds of communication, speeds of internet are going to be in terms of gigabytes. With that technology coming in, let us say there is no need for urbanization. That means people will not migrate to urban cities. That could be another other scenario. Let us imagine if that happens, then the cities are not going to grow. That means your entire rural area is going to get developed because people can sit there and work and contribute in the same way as what they are doing in the cities. So these scenarios can be analyzed using a computer. That's a fantastic opportunity for smartness in terms of generating a product idea. Based on the scenario analysis, then you create contextual hints which would go into do how, for example, and then create a free flowing free thought workshop for generating new ideas. The next one would be hackathons and innovation workshops. What is a hackathon? Hackathon is basically to try to solve a problem. That's the way it started. You're basically trying to hack a particular server, a particular application, and do everything to hack it so that you're in a position to break the code. And that's something which is going to make the product which is being hacked much more robust, because they'll know as to how people are going to hack, and then they can plan sufficient security options to ensure that it will not get hacked. So during the hackathons and innovation workshops, you again get ideas. This is typically done in the colleges, in the education space, where one could also use technology to really look at hackathon is definitely 100% technology based, because you're only talking about how the computer networks can be hacked, can be vulnerable, and how programs can be vulnerable, applications can be vulnerable. Innovation workshops, on the other hand, could be to talk about solving common problems. In fact, our Do How game for colleges talks about this, where we talk about where there are topics where the kids have to talk about how are they going to improve the garbage collection in the cities, how are they going to improve the recycling of water in the villages, things of that kind, which generate new possibilities of ideas. And these two also are extremely important, because that is a source for new ideas coming from the new generation. There again, technology can be used, like I said, by providing directions in terms of what needs to be done. So as far as the product cycle is concerned, mainly it's about thinking and creating a product. For us to come to a level where a computer, a system, can really conceptualize new products for the humans to live, I think that's going to be science fiction. It possibly would happen maybe definitely not in my lifetime, but at some point of time it may happen, where the computer is really thinking and generating new product ideas, new applications, where one could start talking about developing them. So today I spoke about product cycle, and tomorrow my discussion would be on the minimum viable product. Once the product idea is there, the most important thing is to do get the idea executed. I'll talk about that tomorrow, what kind of smart manufacturing can be done in that area. So thanks a lot for watching. For those of you in India, have a nice evening. For those of you outside India, have a great day ahead, and see you both tomorrow, more or less at the same time, 8:30 Indian Standard Time. Thank you and goodbye.